4.7 Composition of Functions. So the first thing we're going to talk about are inverse properties. So if x is between -1 and 1 and our y is between -pi/2 and pi/2, then when we take the sine of the arc sine of x, we're going to get x. They basically cancel out. Or if I do the arc sine of the sine of y, I'm going to get y. Again, they get to cancel each other out as long as our domain and range are correct. Again, with cosine, as long as our domain and range are correct between -1 and 1 for x and 0 and pi for y, then our sine, or then our cosine and our arc sines can cancel out. And then with tangent, same thing, as long as we fall into the correct domain and range. So as long as our x is a real number, which it's going to be, and as long as y is between -pi/2 and pi/2, then tangent and arctan can basically cancel out, and I'll just be left with the number on the inside. Okay, so for this first part, we have tangent of the arctan of -5. So the first thing we want to make sure is, first of all, we're taking the arctan of x. So our -5 right here is an x. I take the inverse of, not the angle. Remember, the inverse is equal to the angle, right? So when we're taking the arctan of x, we want to make sure that x falls into the right category. Is -5 between -infinity and infinity? Sure is, absolutely. So it falls in that domain, which means tan and arctan can basically just cancel out. I'm going to get -5, and that's because the -5 fell into the correct domain. All right, how about the arc sine of the sine of pi, or 5pi/3? So I want to make sure, first of all, this is a y here. I take sine of y, okay. Is 5pi/3 going to be in the correct range here? It's not. 5pi/3 is too large. So what I could do is see about maybe a coterminal angle, if that will fall in there. So if I add 2 pi, that's definitely not going to be within that range, but maybe let's try subtracting 2 pi. So we're going to get a coterminal, and we could just do 5pi/3 minus 2 pi. We need a common denominator. So really that's 5pi/3 minus 6pi/3. That's going to give me -pi/3. Now -pi/3 does fall within that range. So we can pretend that this problem said the arc sine of the sine of -pi/3. And now arc sine and sine can cancel, and I'll get -pi/3 as my answer. Okay. And lastly, we want to know the cosine inverse is the same as arc cosine. It means the same thing, of pi. So I take the inverse of x. So pi is really my x here. So I want to know, does that fit this domain? Well, I mean, it does, actually it does not, does it? It fits the range. It doesn't fit the domain. This is an x. Pi is about 3.14. X is supposed to stop at 1. So we say that this is not defined, or that this is undefined, because this does not give us, we don't fall within that domain. We have that domain error because this is supposed to be an x. Okay. Using right triangles to find the exact values of the composition of inverse functions. So the first thing we're going to do is keep in mind that an inverse function is really going to equal an angle. Okay, so when I see the arc cosine of 2/3, this is actually equal to an angle. Okay, what that means is cosine of some angle, theta, is equal to 2/3. That's what that really means. That's what the arc cosine of 2/3 is really saying. Okay, so what do I have to do? Well, I need to think about this. I could think of this a few different ways. Let's start with a triangle. Okay, so let's do a triangle for cosine of theta. So pick a corner to be theta. If we have cosine, this is the adjacent over the hypotenuse. So adjacent would be 2, hypotenuse would be 3. Really, this in parentheses here is this angle right here. I want to take tangent of this angle. That would be opposite over adjacent. I already know the adjacent is 2, so I just need to find the opposite. I can do the Pythagorean theorem. So we have a squared plus b squared is equal to c squared. So a squared plus 2 squared is equal to 3 squared. So a squared plus 4 is equal to 9, which gives us a squared is 5. So we're going to get a is the square root of 5. Okay. All right, let's try the next one. So we see we have arc sine on the inside there, which means this is really just an angle. Okay. This says the sine of some angle is equal to negative 3 over 5. Okay, the sine of some angle is equal to negative 3 over 5. So let's draw a triangle for that. Remember, my hypotenuse is never going to be the negative here. So we've got 5, and if this is my angle, and then negative 3. Okay. All right, so we know this is a 3, 4, 5 triangle, so I can use that. Okay. The next thing I want to do, since I don't need Pythagorean theorem, is think about cosine is equal to what? Well, cosine is going to be adjacent over the hypotenuse. I know the hypotenuse was 5 from before. So my adjacent is going to be 4. And I just want to double check, should this be positive or should this be negative? So I want to think about what my restrictions really are. So my arc sine, for arc sine, I'm going to have that my angle has to be between negative pi over 2 and pi over 2. That's that first and that last quadrant. So all students take calculus, okay? So if we're between pi over 2 and negative pi over 2, which is really what this angle must be because of this, we're somewhere over here. All students take calculus. Cosine is going to be positive no matter which side I'm on. So 4/5 is going to be just fine. Okay, and then lastly, we can make this a little bit trickier. Instead of actually having a real value, we might have x, but it's really the same process. So we want to keep in mind that the arc cosine of 3x is really just representing an angle. What this is saying is that cosine of some angle is equal to 3x, so technically over 1, because anything can be a fraction over 1. That's my adjacent, that's my hypotenuse. So let's draw a triangle. All right, so here's my angle. We said adjacent is 3x. My hypotenuse is 1. I need to do the Pythagorean theorem to find the other side. It's just going to be a little bit messy. So I've got a squared plus b squared is equal to c squared. So that's a squared plus 3x, don't forget parentheses, squared is equal to 1 squared. So that's a squared plus 9x squared is equal to 1. We'll subtract, so that's a squared equals 1 minus 9x squared. And I'll take the square root, and unfortunately, there's really nothing I can do from there. I can't take the square root of each of those things separately because of that subtraction. So that missing side is going to be the square root of 1 minus 9x squared. It is what it is. It's a little messy. Not a big deal, just kind of messy. We could keep in mind a domain here, but it's really not all that necessary to worry about. So don't forget, sine is going to be opposite over hypotenuse, which makes this, the opposite is that radical over the hypotenuse, which is 1, so it just is that. All right, how about the next one? So on the inside again, remember this is representing an angle. So what this means is that cosine of an angle is equal to 3x, technically over 1. In reality, it is the same triangle because it's the same numbers. It just is a coincidence here, so 3x and 1. We don't have to Pythagorean theorem again because it's, well, the same problem, 1 minus 9x squared. This time instead, I want to take the cotangent of that angle. Remember, cotangent is just tangent flipped over, so that'll be adjacent on top this time and opposite on the bottom. So the adjacent is 3x. The opposite is the square root. And it's perfectly fine to leave this. I know it's not rationalized, but with the variables, it's just not worth our time to get rid of that radical.